When you think of construction, what comes to mind? Probably steel, concrete, brute force, right? But what if I told you the next huge building material isn't something you can touch at all? It's data. That's right, today we're jumping into Construction 4.0 and looking at how the Internet of Things is completely changing the game. No, really, just think about that for a second. What if a construction site could actually think for itself? I mean, a site that's not just a patch of dirt and machinery, but one that's kind of alive. It can sense what's happening, it can communicate, it can even predict problems before they start. Every piece of equipment, every pallet of materials, all connected, all intelligent. Sounds like sci-fi, I know, but that's exactly what IoT is making possible in construction right now. All right, here's how we're going to break it all down. First, what even is construction IoT? Then we'll get into the key tech that makes it tick. We'll see how it's used in the real world, including a really cool case study on smart tunnels. And we'll wrap up by looking at what this all means for the future. Okay, first things first. What are we actually talking about when we say construction IoT? Okay, that's the official fancy definition. But let's cut through the jargon. All IoT really means is taking a regular physical thing, a concrete beam, a generator, heck, even a hard hat, and hooking it up to the internet. Once it's connected, it can send and receive data. It basically gives it a digital voice, which makes that object smart. And here's why that's a huge deal. It's about flipping the script from being reactive to being proactive. Think about it. Normally, we fix a machine after it breaks down, right? We deal with a safety issue after something's already gone wrong. Well, IoT lets us get ahead of all that. It gives us the data to see a problem coming, to predict a machine is about to fail, or to spot a dangerous situation before anyone gets hurt. So IoT isn't just one single thing. It's not some magic black box. It's more like a whole toolbox with a bunch of different pieces of tech that all have to work together. So let's pop it open and take a look at what we're working with. First tool in the box, RFID. The easiest way to think about this is like a super smart barcode, or maybe a digital dog tag for everything on site. You can slap an RFID tag on pretty much anything, a stack of drywall, a piece of heavy machinery, you name it. Then a scanner can pick it up automatically without even needing to see it, and boom, the system knows exactly what it is and where it is. Okay, so if RFID gives things a name, then wireless sensor networks, or WSNs, give the whole site its senses. This is basically the site's digital nervous system. It's a whole web of tiny smart sensors that are constantly monitoring stuff like temperature, vibration, air quality, even the amount of stress on a building's frame. They're like the eyes and ears of the entire operation. So you've got all these sensors. How do they all talk to each other? Well, you've got options, and it's all about picking the right tool for the right job. You could use Wi-Fi, which you know is super fast, but look at the battery life. We're talking hours. That's a huge power drain. For a tiny little sensor that only needs to send a small bit of data, like a temperature reading, every hour or so, that's total overkill. That's where something like Zigbee is perfect. Yeah, the data rate is way lower, but who cares? Check out that battery life, more than a year. And it can handle over 65,000 devices on one network. It's cheap, it's reliable, it's exactly what you need for a sprawling job site. And the last piece of the puzzle is BIM, or Building Information Modeling. So if RFID tags are the name tags and the sensors are the nervous system, then BIM is the brain. It's this incredibly detailed 3D digital model of the entire project. And it's not just a fancy 3D drawing, it's a living database. All that information from the sensors and tags gets pumped right into this model, so everyone is looking at the same up-to-the-second picture of what's happening. All right, so we've seen the tools, now for the fun part. Let's see how they all come together to solve some actual real-world problems on site. And man, the possibilities here are just massive. You've got safety management. Imagine sensors sniffing the air in real time, warning workers about dangerous gases they can't even see. Then there's the health of the building itself. Sensors buried in the concrete of a bridge, keeping an eye on its structural integrity for decades. Or logistics, tracking a custom-made part all the way from the factory to the moment it's installed. But for right now, we're going to focus on what's maybe the most important one of all, safety. Okay, let's get into a case study where this stuff is literally a matter of life and death. We're talking about safety during tunnel construction. So here's the problem. Building a tunnel is just plain dangerous. You're deep underground in a really confined space, and there's not a lot of ventilation. That means toxic gases can build up fast and without any warning. The old way of doing things? Send a person in to check the air. That's slow, it takes a lot of manpower, and you're putting the person doing the checking in danger. And here is the brilliant solution. It's called a cyber-physical system, which is just a fancy term for a system that links the physical world, the tunnel, with the digital world of data. Let's just walk through this. At the very bottom, in the actual tunnel, you have your sensors collecting all that real-world data. That data gets sent up to a database where it gets organized and plugged into the BIM model. An application layer then makes sense of it all. And finally, at the very top, you have the presentation layer. That's the dashboard the site manager sees, giving them a simple, clear picture of everything. And this right here shows you how it all connects. On the left, that's the actual hardware, the little sensor box that's sniffing for methane and checking the temperature. See? It's using that Zigbee tech we talked about to send its data wirelessly. Then on the right, you see the result. That data pops up right on the 3D BIM model, the tunnel's digital twin, showing the managers exactly what's going on and exactly where it's happening. Now, this wasn't just some theory they cooked up in a lab. They actually took this system and put it to the test in a real subway tunnel that was being built. They set up these little sensor nodes every 100 meters or so, creating this chain of digital guard dogs running the length of the tunnel, all sending information back to one computer. And here it is, the moment of truth. During the test, they released a bit of flammable gas near the first sensor. And what happened? Instantly, the system caught it. Just look at that dashboard. You can see the gas level for location 1 shoot way up. And on the 3D model, a big red alert pops up, showing exactly where the danger is. The system can even be set up to automatically sound alarms or kick on the ventilation fans. That is what proactive safety looks like. So, that tunnel example, it's really cool tech for sure. But it's also a sign of something much, much bigger happening in construction. So what's the main point we should be taking away from all this? It all comes down to this. We're moving away from writing up reports after an accident happens, and we're moving towards preventing that accident from ever happening in the first place. That's the real power here. It's about changing a job site from just a bunch of separate, dumb pieces into one smart, connected system that's actively looking out for people and making everything run better. And that really leaves us with one last big question to chew on. If we can make a construction site into an intelligent ecosystem, what happens after the construction is done? What does that mean for the things we're building? If we can build a smart tunnel, why not a smart building? Or a smart electrical grid? Or an entire smart city? The way we build is changing, and that's going to change the world we all live in.